So yeah, hello. Took a while, but here we are. Yeah, so I want to talk about maybe an approach that we could take for essentially modernizing and changing a bit like how our system components are working. So essentially the context here is that I'm not going to talk about apps or anything. I'm only talking about system components, which means like something like the compositor and all the daemons that we have, and like everything that's around the apps essentially. Like everything that's not an app is a system component. So yeah, I've been working on a bunch of those parts of the stack, like mostly mutter, Flatpak, and portals at this point. And it's all written in C, which is on the one hand, like it's nice that it's all the same language, but like it's C. But on the other hand, also GLib has been super helpful with dealing with C issues, like the entire auto pointers, ownership, transfer. Like there's a lot of interesting and good things in GLib that make dealing with C actually like bearable. So yeah, it has been super helpful. I think it really improves like our code in general. But it's like a language from the like 70s, 80s, whatever. Like it's not gonna solve all the issues. Specifically, what it is not solving is like memory safety, and it also doesn't have like this nice zero-cost abstractions. Like whenever you write a loop in like C, it's still a loop where you like specifically have to write the loop and then do stuff in it and whatever. And like Rust has this nice abstractions where you just call iterators, functions, and it does a lot of things in like very few lines of code. There's those new languages, they have their advantages, and like it would be nice if we could use them. Specifically, the memory safety stuff I feel is important, especially because we now have like a lot of security issues that are being surfaced, thanks to LLMs being kind of good at looking at code. So yeah, the idea is then essentially like, can we just use Rust for our system components? And essentially, like, if you currently try to do this, you're going to see some certain patterns. Like, you still need to consume something from our stack usually. Like, you want to deal with applications, you want to deal with GNOME-specific things. Like, you want to use some libraries that already exist. So, like, you're going to use something from glib, some kind of G-object bindings that you're going to use from Rust. Can be like about desktop files, about how to actually spawn an application, which is like much more interesting than just executing a binary. Things like MIME handling, and there's a bunch of other XDG specs which kind of you get from glib, and which you don't really get by default from the new languages. And usually, like system components, also you want them to be consumable. Like they do something on behalf of something else. So like they have to be either consumed via some IPC thing or like via G-object bindings usually. And if you try to actually do this, you run into a bunch of issues when you use Rust together with glib and G-object things. If you do anything that involves some async work, you will use something like Tokyo in Rust, and then you have a main loop there. And then you have glib, which has its main loop, and then you suddenly have to get stuff from the one main loop into the other one, and it's just kind of messy. And if you use the G-object bindings that we have for Rust, then there's a whole bunch of issues around. For example, if you want to use signals, then you need a callback, and the callback has a lifetime of static, which means that you suddenly have to do some weird ref counting things to make it, like, to work around all of this, like, mismatch. There's a whole issue about how object orientation from G-object is exposed to, like, the trait system that Rust has, where, like, you use different traits to implement basically the subclasses and everything. The safety thing is also kind of weird because in theory, everything in Rust is safe as long as you don't use unsafe, like memory safe. But the Rust the G-object bindings kind of sometimes destroy this because they might not be safe, and like it's not entirely sure all the time that like the auto-generated bindings actually are entirely safe. So it doesn't really compose that well as well. And it's in general, also the people who are maintaining the bindings are doing some great work, but they're also not really happy with it. Like, it's not a great system. So like the question here really is, can we just drop glib essentially when doing Rust? Can we just not use gobjects and anything that comes from it? Yeah, what it would mean is essentially that we are not going to use any kind of gobject library that you're just, yeah, like any bindings that currently rely on gobject. And instead, we're just going to use more IPC, essentially. Like, we're going to expose things via Varlink. We're going to do the normal thing that you do in Rust when you are not using, like when you're not on the GNOME stack, which is like you use crates and you get functionality. So essentially, third-party things that you're just consuming. And then we want to expose Varlink, like, but we also want to consume Varlink services. Like we need we need functionality, and we want to expose functionality. And I'm just saying, okay, let's try to do this mostly over IPC. So yeah, there's some simple things actually that we need and that glib provides that are easily implementable in like the language that we want to use, for example, in Rust. Like the XDG base tier specification, for example, is essentially just a bunch of environment variables which are telling you how to assemble a path to a certain thing, like where is my config directory, or like what's the list of config directories in which order. So like that's something you can just implement in the language, and you don't need a service for you to handle this kind of stuff. Yeah, XDG activation tokens, also just environment variable which tells you something about, like it's a semantic for an environment variable. Like you don't need any kind of crazy IPC mechanism for this stuff. Just implement this, it's fine. Like you also don't really need glib bindings for that, so yeah. But there's also like more complex functionality that glib has, and I think that is the point where you kind of want to look into abstracting it out of glib and into your own kind of service that provides something for you. And the kind of things I'm thinking about here are something like file trashing, which seems quite easy on the surface, but like if you ever look at the XDG spec, it becomes kind of a more interesting problem than one would assume. Yeah. Also, if you want to launch an app, this is also not that trivial because you have to parse a bunch of, like, you have to use the XDG base directory specification to find a whole bunch of directories, read all the files from there, then like associate, like read a whole bunch of other files to figure out like which MIME type, for example, something handles, and then you have to figure out how to actually launch it. So there's a lot of things that you actually have to do there. So I'm thinking stuff like that could also be abstracted away into a service which handles all of those details for you. The same for another thing that glib provides is this kind of abstraction over a file where we support, for example, remote files like SFTP, where you just access the thing, the UI, and it magically works. And I would like say that we should use more Fuse for that as like services where you can just tell the Fuse, like a specific Fuse file system that you want to access something instead of like abstracting this away in glib in the file API. Okay, so I've been saying we should use more IPC, but like the question is like, why would we want to use Varlink? The obvious ones, like it makes functionality available to other processes. It is language agnostic, and it's kind of simpler and not dbus, essentially. Like, as much as we usually know how to deal with dbus, other people are often confused by what's going on, the complexity around it and everything. So the whole it's not dbus thing, it also comes down to it being not a bus. It's a direct connection. It's essentially a Unix socket, and you just write a bit of JSON to it. And because it is like this direct connect Unix socket connection, it also means that you avoid all the context switching that a bus system gives you and like multiple encoding, decoding steps and all of that stuff. It supports socket activation, so you don't have to run the service. You just, the service can be activated by something like systemd. You can essentially, because of the socket activation thing, you can essentially handle a single connection in one execution instance of a process. So a connection comes in, the socket gets accepted, it will hand off, like execute your program for specifically this connection. You will deal with the connection and then exit. You can also, like, a nice feature is that you essentially can run the thing as a normal command line app. It will be essentially the same code. You just have to change a bit where you're reading the input and the output from. It's also really simple because it's just JSON, and you also do a bit of FD parsing because it's usually what you want to do over like system services. We also, like, it's kind of easy to observe what's going on. If you just strace a process, you can see the Varlink calls being made because it's just JSON strings. There's also nowadays a registry for the available services. They kind of added this with systemd a few versions ago, and we are also working on some monitoring solutions. So something like dbus monitor is also working for Varlink then. And it also supports protocol upgrades where you can just use Varlink and then say, okay, I now want to use another kind of thing, another protocol. And obviously, like, there's a lot of implementations of Varlink because it is quite simple, because you just need to send a bit of JSON around and accept file descriptors. You can just implement something really easily. We have an implementation which is like usable from GLib. Christian Hergert wrote one, which is, I forgot the name, G-Varlink maybe? I don't know anymore. But it's using, like, you can use it from C with libdex and async. It's really nice. Systemd has theirs. Rust obviously has Z-Link. There's also implementation in Python. So, like, a lot of languages supported nowadays. And, like, I think one of the big advantages of Varlink is specifically that the socket-activated case is kind of neat, because if you want to implement a service, what you usually end up with is this kind of service architecture where you start a process, you then have you create the socket that you're listening on, and then you accept connections on that socket, and then you need a way to concurrently handle multiple connections, and that means that you need some kind of async or threads or like something that handles all of that stuff. And if you just do the socket activated thing, then the only thing that you have to do is handle a single connection in your process. And that usually makes implementing things really easy. Like if you want to implement a trashing service, then you would implement essentially trashing for a single file. And that's all the executable has to do. And it becomes a service just by being socket activated and speaking Varlink. Yeah, but also because it is just Varlink and just the normal socket service thing can work. So you can still do the more complex cases just like you could do with dbus previously. Yeah, another thing that kind of, so Varlink is kind of new compared to dbus, which means that there's still a lot of cases where we don't have great answers yet. There are usually patterns in dbus that we use where we know it works. With Varlink, it's a bit more complicated because the patterns don't exist yet. But usually you can figure out something nice. But it's also a good opportunity to start using it and actually make it do the things that we need it to do. Like it's currently mostly used by systemd, which means that they are currently kind of shaping the Varlink ecosystem. but they're also open to like suggestions and like to, improvements that you might have, which means that like I think now is a good time to essentially start using Varlink and figure out what we need from it. Because while systemd is really heavily using it, they are not using it for like desktop infrastructure, so they're kind of missing some of the use cases we have found. Yeah, and if you make one of those like Varlink services, it also turns out that you essentially just almost made a portal already if you go for one of those services. Like portals are usually the things that we use, that we expose to applications, like services that applications can use, even sandbox ones. So if you make a Varlink service, for example, a trashing one, like you want to trash a file, and we separate it out as a service, not only system components could use it, like we could also expose this to applications. It is possible what we're currently also doing in portals, but if we wanted to do this with Varlink, we could have the opportunity to essentially do a new kind of portal system. And all you would have to do essentially to turn this into a portal is query like the information about the app identity, which we have a plan for, which would also be just a Varlink call. And then you would, based on the identity, kind of have to restrict what the application is allowed to do. And if you do all of that and you just put a socket in the right path, we can just mount that inside the sandbox for Flatpaks, for example, and it will just magically appear as like a service that the application can use, and it will just do the right thing. So I think it would not just be great for system services to talk with each other or with like other system components. We actually could use the same approach to essentially give applications the APIs they need. And I think that's already all. So I apparently managed to cram this into yeah. Thanks.
Thank you, Sebastian. If we have one question, I think we can take it. It's a big venue. Just give me a second.
Thank you. I'm cheating. I have two questions. The first one is, some of us are dumb enough to have multi-OS support. So how would Varlink play with Mac OS or Windows? The other question is, to me it seems like GObject has 90s derivative, whatever, inheritance. And the question to me is like, wouldn't it be nowadays perhaps be a good way to get rid of that in a GObject 2, which is more component-based?
Okay, so the one is easy. Like on Mac, the stuff works well. Varlink just works there because it's like just a Unix socket and FD parsing and JSON, so that's not an issue. For Windows, I actually don't know. Never looked into that. But sorry? Okay. Yeah. Okay. You might have to design things in a different way there, but like, for example, portals are already very Linux, Unix specific, and we still kind of manage to do apps with them. So I think your question was targeted like how apps would consume that, right? Yeah. The other question about like maybe just doing another GObject kind of thing, no. I think people have kind of tried. I think Ibasi kind of presented something like a vision for how to get away from GObject and still being like on a G-type system. And it's like, you can try that, but I feel like there's probably still going to be a lot of mismatch. You still have like the problem that you have to port everything. Like, and I also don't think that it really, like the bindings are an issue. Like you have to write bindings for every language where you want to use it. You have to maintain it. Like it's kind of a lot of work, and it's not working that well sometimes. Whereas like an IPC mechanism usually just works in every language, and you just get things for free, kind of. So that is the reason why I would prefer if you just do more IPC. instead of trying to come up with a new GObject kind of thing. But also, if people want to do a new GObject thing, like, sure, like, why not? I think they're not mutually exclusive.
So yeah, I think that's it. If you have any, okay, I see people raising their hands. Let's do one more question.
So, I mean, the interaction between like server-client applications at this point is going to be simplified, but at the same time, you might still require, you know, the signaling situation that we have in the bus. So we basically end up to have two servers speaking together, right? To have something like that. Now, do we plan somehow to have some wrappers or some simplification to easily allow to create like this kind of interactions that we have in the bus? So you do a call, an async call or whatever, you get an answer back asynchronously or signaling back and this kind of stuff. Can we somehow wrap it into something like which make it easier to replicate that scenario?
Yeah, I'm not entirely sure what you're asking. Yeah, are you asking about existing dbus things or?
Replicating the same kind of process interaction we have now in the bus. So we have, you know, basically you can call and reply back and signaling, which are not possible in Varlink.
Right, Varlink has a bit of, like, it has a few limitations, but like it mostly comes down to broadcasting. Like everything else you can just kind of replicate with just normal Unix sockets and sending requests, like calls and responses. You can also do a thing where you use multiple Varlink connections, like you spawn a new connection on that connection if you want to have a thing that is essentially a signal. There are ways to work with Varlink to get most of the things. Broadcasting is one of the few things that it doesn't support. But I don't think that it usually is a big deal. Like, I'm not aware of like any cases where broadcasting is really a big thing. You can just send a message on a bunch of connections and it's probably fine.
Hello. So I have one last question from the chat, just because we haven't had any questions from people attending from home so far. So FD passing is just an implementation detail of SD Varlink and Varlink GLib, when the medium is a Unix socket. Any plan to create an extension spec so implementations can be on the same page?
Yeah, so Varlink is a bit underspecified, but like essentially what systemd is doing is like pretty much the spec, which is not ideal, granted, but on the other hand, essentially the SD parsing stuff is implemented by every Varlink library that exists, so I don't think like in practice it's a big deal.
Thank you. Thank you very much, Sebastian.
Thank you.